We also provided students with the historical overview of AI, the history behind artificial intelligence, and its diffusion into the various industries and the adoption of AI in business using our different backgrounds. And also the impact. We looked at the impact of artificial intelligence, and we concluded that in this 21st century, for a business to survive, for a business to make an impact, there is need to adopt artificial intelligence. So today we're going to look at machine learning in business. Now, machine learning is just part of a component of artificial intelligence. So we're going to look at it, and I hope we're also going to be practical in our approach. Maybe I'll start by introducing what machine learning is, and then we look at the tools that we use for machine learning, and we build our first machine learning model. So that will be the outline for today's lecture. So I'll start by sharing the slide that I have here. Let me share this slide. Looks like, let me try to link this slide here. Can you see the slide?
Not yet, sir, from my end.
All right. How about now?
Yes, now I can see it.
Wonderful. So I'll start by introducing what machine learning is and look at how best businesses can benefit from machine learning. So what is machine learning? Like I said before, it's a branch of artificial intelligence, all right? It's a branch of artificial intelligence. And the idea underlying machine learning is that we give a computer program access to lots of data and let it learn about relationships between variables and make predictions, all right? So we load the computer, we create a computer program and load it with lots of data and allow it to learn the relationships between the variables and ultimately make predictions. Some of the techniques of machine learning date back to the 1950s, but improvements in computer speeds and data storage cost have now made machine learning a practical tool. Now, you agree with me that in this era, in this age of big data, we are all generating data. We are not only consumers, but each one of us is not only a generator, but also a consumer of data. We want to have products and services specialized for us. We want our needs to be understood and interests to be predicted, all right? But way back, only companies had data, and there used to be computer centers where that data was stored and processed. But now with the arrival of the personal computer and later with the widespread use of wireless communications, we all became producers of data. Every time we buy a product, every time we rent a movie, every time we visit a web page, you write a blog or post on the social media, you write a tweet, or you post on Facebook. Even when we just walk or drive around, we are generating data. So we're in that era of big data generation, all right? So we are generating, and we are also consumers of this data. Let's think of, for example, of a supermarket that is selling thousands of goods to millions of customers, either at a brick and mortar store, or over a country, or through a virtual store, or over the web. The details of each transaction are stored. That is the date, the customer ID, the goods bought, and their amount, the total money spent, and so forth. So we keep track of all this information of a transaction. This typically amounts to a lot of data every day. What the supermarket chain wants is to be able to predict which customer is likely to buy which product to maximize sales and profits. Similarly, each customer wants to find the set of products best matching his or her needs. So this task is not evident. We do not know exactly which people are likely to buy this ice cream flavor, or the next book of this author, or see this new movie, or visit this city, or click this link. Customer behavior changes in time by geographic locations. But we know that it is not completely random. People do not go to supermarkets and buy things at random. When they buy, for example, when they buy beer, they buy chips, they buy ice cream in summer, and spices in winter. There are certain patterns in the data. So there are certain patterns that these customers generate in their buying trends. So to solve a problem on a computer, we need an algorithm now. Now, an algorithm, we said, what did we say is an algorithm? Anyone who can tell us what we said is an algorithm? Do you remember? No more. What did we say is an algorithm? No more? Go ahead.
Good day. I forgot.
All right, maybe Anthony can help you. What did we say is an algorithm? Anyone who can come in?
Hello, sir.
Yes, Doc.
I think these are a set of rules. I may not be very accurate, but these are rules that you are using maybe to carry out an operation, something like that.
Thank you, Doc. Thank you, Doc. Timbalami, you had your hand up. Timbalami. All right, like just what has been said by Dr. Famba, these are basically rules. Yes, go ahead.
Yes, last time you said it is a series of steps which is prepared or developed to solve a particular problem, or a programming that is used to, hello?
Go ahead.
Or a programming that is used to teach a computer how to learn by itself.
Yes, thank you very much. So these algorithms in machine learning, we are training the computer to develop an algorithm to understand these hidden patterns of customer data. So basically, an algorithm is a series, is a sequence of instructions that should be carried out to transform the input to output. For example, one can devise an algorithm for sorting. The input is a set of numbers and the output is their ordered list. You see? So the input will be just a list of numbers, and then the output is now the list which is in an ordered manner. That's for sorting. So we can have a sorting algorithm. So for the same task, there may be various algorithms, and we may be interested in finding the most efficient one, requiring the least number of instructions on memory or both. So there could be many ways of sorting numbers, but in machine learning, we're interested by the most efficient one in terms of usage of computer resources. When we talk of computer resources, we're talking about the RAM, the computer memory, and the performance of the algorithm. So these algorithms actually perform differently, but ultimately in machine learning, we choose the most efficient algorithm, okay? But for some tasks, however, we do not have an algorithm. Predicting customer behavior is one. Another is to tell spam emails from illegitimate ones. We know what the input is, an email document that is, in the simplest case, is a file of characters. We know what the output should be, a yes or no output indicating whether the message is a spam or not. But we do not know how to transform the input to the output. What is considered spam changes in time and from individual to individual. So to really say we have this algorithm to classify these emails as to whether it's a spam or not, where yet it changes over time, is quite a tricky one, okay? Because what we lack is knowledge. We make up for in the data. We can easily compile thousands of example messages, some of which we know to be spam and some of which are not. And what we want is to learn what constitutes spam from them. The word learn there is very critical, it's very important. In other words, would like the computer or the machine to extract automatically the algorithm for this task. So we want the computer to generate the algorithm for this task which changes over time. We want the computer to learn. Hence, we now have machine learning or computer learning. It's learning from the data that we provide to it. All right? So there are different forms of machine learning, but I think we'll talk about them later on. So we may not be able to identify the process completely, but we believe we can construct a good and useful approximation. The approximation may not explain everything, but may still be able to account for some part of the data. And we believe that though identifying the complete process may not be possible, we can still detect certain patterns or irregularities. This is the niche of machine learning, that is machine learning. Such patterns may help us understand the process, or we can use those patterns to make predictions, assuming that the future, at least, or the near future, will not be much different from the past when the sample data was collected. The future predictions can also be expected to be right. So application of machine learning methods to large databases is called data mining. So sometimes you can have huge amounts of data as a company or as a business. You've got databases that you use to store your data. And if you want to retrieve some patterns from these huge amounts of data, we call it data mining. The analogy is that a large volume of earth and raw material is extracted from a mine, which when processed leads to a small amount of very precious material. Similarly, in data mining, a large volume of data is processed to construct a simple model with valuable use, for example, having high predictive accuracy. And its application areas are abundant. In addition to retail, in finance, banks analyze their past data to build models to use in credit application. All right. So I was saying, in finance, banks analyze their past data to build models to use in credit applications. First event, can you mute? All right. We can also apply machine learning in fraud detection and in the stock market. In manufacturing, learning models are used to for optimization, control, and troubleshooting. In medicine, learning programs are used for medical diagnosis. In telecommunications, call patterns are analyzed for network optimization and maximizing the quality of service. And in science, large amounts of data in physics, astronomy, biology can only be analyzed fast enough by computers. And the World Wide Web is huge. The World Wide Web is huge. It is constantly growing, and searching for relevant information cannot be done manually. But machine learning is not just a database problem. It is also a part of artificial intelligence. To be intelligent, a system that is in a changing environment should have the ability to learn. We appreciate that the environment, it keeps changing. The environment keeps changing. So our machine learning system should be able to keep up the pace and learn as the environment changes, all right? And if the system can learn and adapt to such changes, the system designer needs not to foresee and provide solutions for all possible solutions. So machine learning also helps us find solutions to many problems in vision, speech recognition, and robotics. Let us take the example of recognizing faces. How, if I may pose a question, how do you recognize that this is Dr. Famba? How do you recognize that this is your mom, this is your dad, this is your child? How do you do that? How do you recognize faces? I'm sure this is an effort that we do. We do this effortlessly. Every day we recognize family members and friends by looking at their faces or from their photographs or pictures, despite differences in pose, lighting, hairstyle, and so forth. But how do we do that? And we do this unconsciously. How do we do that?
Okay,
yes,
can I try, Doc?
Yes, go ahead.
Okay, I think it is easy for us to recognize the people we know or friends or family, just like you mentioned, based on the memory we have of those people. To say, for example, I should have seen Dr. Famba before for me to recognize him today or tomorrow. So I think it evolves around memory. You can't recognize or remember something you have not seen before.
Yes, it's because our mind has been trained, isn't it? You have been taught that this is Dr. Famba and you've seen him, and then that sticks in your mind. So how then do we so we expect the computer to do the same now in machine learning. How does it learn? we give it previous data. All right, give it previous data. Then when it sees this new data from the what it is learned or what it has been told before, it is now able to what? To recognize what? Faces. Okay. But at the same time, we know that the face image is not just a random collection of pixels or a face. If a face has got structure, isn't it? It is symmetric. They are the eyes, the nose, the mouth, located in certain places of the face. All right. By analyzing sample face images of a person, a learning program captures the pattern specific to that person and then recognizes by checking for this pattern in a given image. So there's a pattern that is going to be picked by this machine learning program. And then the next time it sees the same image, it now checks with what it has got stored, and then it can now tell, all right? This is one example of pattern recognition, okay? So there's that pattern that each and every face has got, which is kind of unique. And this pattern is the one which is going to be stored by the computer, so much that next time it sees the image, it is able to tell. So machine learning is programming computers to optimize a performance criteria using example data or past experience, like what has been said. Past experience or example data. So I think you can hear now from this discussion that data is very, very critical. If we want to develop a machine learning model which is effective, data is very, very important. Okay. Without data or with limited data, the accuracy of our machine learning model is going to be what? Is going to be somewhat compromised because it has been trained with limited data. Okay, so machine learning uses the theory of statistics in building mathematical models. So mathematics is in it, that's the background, because the core task is making inference from a sample. So you want to make an inference from a given sample. Then mathematics comes in, statistics comes in, and the role of computer science is twofold. First is in training, okay? Training the model, and we need efficient algorithms to solve this optimization problem, as well as to store and process the massive amount of data we generally have. And then secondly, once a model is learned, it has been trained, its representation in algorithmic solution for inference needs to be efficient as well. In certain applications, the efficiency of the learning or inference algorithm, namely its space and time, we call it the space and time complexity. That's the efficiency of an algorithm. An algorithm is efficient in terms of space. How much space is it using? Okay. And time. How much time does it take to execute the given task? Okay, that's very critical. So some of these techniques of machine learning, they date back to the 1950s, like we said in our overview, that this is not a new thing. But improvements in computer speeds and data storage cost have now made machine learning a practical tool. Because of these improvements in hardware and the cost, we are now seeing that rush towards machine learning machine learning models. All right. Now, maybe before getting to the softwares that we use for creating these machine learning models, Maybe we can talk about briefly about examples of machine learning applications. Examples of machine learning applications. Like I said before, in the case of retail, for example, a supermarket chain, one application of machine learning is basket analysis, which is finding associations between products bought by customers. If people who buy X, all right, X is a product in this case, typically also buy Y, which is another product. And if there's a customer who buys X and does not buy Y, he or she is a potential Y customer. Once we find such customers, we can target them for cross-selling. All right. But in finding an association rule, we need to find an association rule. So much that we know that if someone buys chips, the probability that this person is also going to buy a drink is also very high. So there's an association between chips and drink. Okay. So now we are going, if we find a customer who only buys chips, all right, and is not buying a drink, this customer is a target for us to market the drink, because there's an association between chips and drinks. So in finding an association rule, we're interested in learning a conditional probability. We're now getting into statistics. Conditional probability of the form. We know that probability of Y, YX, where Y is the product we would like to condition on X, which is the product on the set of products. Let us say, going over our data, we calculate that the probability that one buys chips and also buys a drink is 0.7, for instance. So we can define the rule that 70% of customers who buy chips also buy drinks. So 70%, looking at our the amount of customers that we are targeting, 70% is quite a huge number. So that tells us in our marketing, we need to target those customers who are only buying chips and not buying drinks. Okay. So we may want to make distinction among customers where we are saying these customers have good attributes, for example, their gender, their age, marital status, and so on. Assuming that we have access to this information, if this is our database, obviously we've got access to this information, okay? The attributes, which are the properties of our customer, the gender, the age, the marital status, and so on. So if this is a bookseller, instead of a supermarket, for example, products can be books or authors, depending with the type of business that you are running. Okay. So in the case of a web portal, items correspond to links to web pages. All right. Those links that we click and web pages, and we can estimate the links a user is likely to click and use this information to download such pages in advance for faster access. So we can actually predict that the user is going to click this link, and then we download before time for faster what? So here we're talking of association rules. All right. Normally this one is for the retail market. And then another application area of machine learning is classification. Okay, classification. A credit is an amount of money loaned by a financial institution, isn't it? For example, a bank to be paid back with interest, generally in installments and so on. So it is important for the bank to be able to predict in advance the risk associated with a loan. The risk associated with a loan, which is the probability that the customer will default and not pay the whole amount back. And this is both to make sure that the bank will make a profit and also to not inconvenience a customer with a loan over his or her financial capacity. So we have what we call credit scoring. Okay, the bank calculates the risk given the amount of credit and the information about the customer. Do we have someone who's coming from the banking sector in this class? I think they understand this better. Someone from the bank where you do these, you give loans to your customers and all. No one from the bank. Tafazo, you said you're coming from the SME. Is that so? SME. Do I still have people?
Yes, we are following.
Yes,
we are following.
Yes, you are following.
Wonderful, wonderful. You know, with these visual lectures, you constantly need to check your audience. Sometimes you end up talking on your own. So I wanted you guys to come in terms of your business environment. You know, we need to relate whatever we're doing here to what you do on a day-to-day basis. And or I'll end up having examples which are not inclined to what you guys are actually doing on a daily basis. But at some point, I think everyone here has got a loan or something from a bank. So we're saying it's a classification problem where we need to classify where the customer we need to score. We call it credit scoring, okay? Where we are calculating the risk given the amount of credit and the information about the customer. So the information about the customer includes the data we have access to and is relevant in calculating his or her financial capacity, namely the income, the savings, the collateral, the profession has got a bearing, the age, past financial history, very important, and so forth. Okay, these attributes or these variables are very critical in terms of our credit scoring. So the bank has got a record of past loans containing such customer data and whether the loan was paid back or not. And from this data of particular applications, the aim is to infer, to make an inference, a general rule coding the association between customers' attributes and the risk. So that is the machine learning system fits a model to the past data to be able to calculate the risk for a new application and then decide to accept or refuse it accordingly. Okay? So this is an example of a classification problem where there are two classes, low risk and high risk customers. The information about a customer makes up the input to the classifier, whose task is to assign the input to one of the two classes. So after training with the past data, a classification rule learned maybe of the form, we can say, what can we say? We can say if income is greater than, let's say maybe we've got a threshold. If income is greater than 500 USD and savings is greater than 300, then low risk, else high risk. So we're kind of creating a rule, a classification rule. If income is greater than 500 and savings is greater than 300, then it's a low risk, else it's a high risk. So the 500, income greater than 500 and savings greater than 300, these are, we call them the discriminant.
Sorry, sir.
Machine learning. Doc?
Sorry for the interruption. I just wanted to check if your slides moving or.
Yes, I'm on software, but before I get into software, I just wanted to give an example of application areas of machine learning. Yes,
that's okay. All right.
All right. So we're saying, like that example, if income is greater than 500 and savings is greater than 300, the 500 and 300, these are the discriminant, which is a function that separates the examples of different what? Classes. So having a rule like this, the main application is prediction. Once you have a rule that fits the past data, if the future is similar to the past, then we can make a correct what? Prediction. All right. So if the rule fits to the previous data, then we can easily what? Predict. All right. Now, let's now talk about the software. Obviously, we have softwares that we use to create these the machine learning models, such as Python. We also have R, we also have MATLAB, Spark, and Julia. These are different softwares or programming languages that we can use for machine learning. So there's a need for the software to be able to handle very large amount of data sets and availability of packages that implement the algorithms. And then Python seems to be winning at the moment. Python seems to be at the forefront, right? So in this lecture, we're going to be adopting Python as the programming language. And Python has got libraries such as NumPy. I think you get to understand them when we get into Python. NumPy, Pandas, scikit-learn, and TensorFlow. They make it easy to handle large data sets and implement machine learning algorithms in Python. Okay. I'm assuming here we have our computers, isn't it? How many of us have got their computers ready? Because at some point we need to install these softwares, the Python. We need to install it, and maybe we also look at how to write the simple Python codes. And also we're going to be using the Jupyter notebook. So I just want to check if we have our computers ready. Do we have our machines ready?
Yes, sir.
Wonderful. Wonderful. And also, I hope we also have connectivity, stable connectivity, because, you know, I could have given you the softwares, but I want us to learn from downloading the softwares, installation. I want us to go through all those processes, and then if time permits, we build our first machine learning model. So we need to have our machines ready. All right. So we have the software. So let's now look at machine learning versus automation. We know that computers have been used to automate many business decisions, the payrolls, sending out invoices, summarizing sales by region, etc. This is digitization, the third industrial revolution. But with machine learning now, it is central to the fourth industrial revolution, where computers are used to create intelligence. So we're using machine learning to generate some intelligence. And this is what is driving the fourth industrial revolution. Okay. We have an example here where I've been talking about it, the loan applications, where we have digitization versus machine learning. If a loan officer applies certain loan rules, we could digitize their activities. But if we do not know the rules used, we could use machine learning to determine them. If we don't know the rules, we just give the computer the data and it can pick the rules. But we could go one step further and use machine learning to improve upon the rules for accepting or rejecting loans. So we have these traditional statistics where we talk about the mean, the standard deviation, the probability distributions, significance test, confidence intervals, linear regression, etc. Again, we use this in in machine learning. But the new world of statistics now, we have huge amounts of data. And then we also have fantastic improvements in terms of computer processing, speeds, and data storage costs. And machine learning tools are now feasible. And we can now develop nonlinear prediction models, find patterns in data in ways that were not possible before, and develop multi-stage decision strategies. So the new terminology now is we have features. What are features? Features are just attributes or variables. All right, features, age, gender. These are examples of what? Of features. We also have labels, okay, where we are labeling our data. And then we also have activation functions. And then we also have the target, we also have the bias, then we also have supervised and unsupervised what? Learning. So this traditional statistics versus machine learning, with the traditional statistics, we develop a hypothesis, we collect data, then we test our hypothesis. But with machine learning, you collect data first, try different models, machine learning models, find patterns or develop a predictive what? Tool. That's machine learning now, okay? You try different, we've got quite a number of machine learning algorithms. So you try them out and you're going to select the one which has got the highest what? Accuracy. Then you deploy your model. So you realize that you need, if the data set is huge, for example, if your data set has got, let's say 1 million rows or 1 million records, then your computer ought to have enough RAM, enough processing power to be able to develop machine learning models which are effective. Okay, but if the data set becomes very, very big, we can actually use a supercomputer. You know that in Zimbabwe we have a supercomputer, isn't it? We have a supercomputer which is housed at the University of Zimbabwe there, under the Ministry of Higher and Tertiary Education. And this supercomputer has got links to all the universities in Zimbabwe. So if your machine is limited in terms of resources, you can now opt to use the high performance computing, the supercomputer, to train your model. And then after enough training, then it can what? It can be deployed. I'm sure many learning institutions have got a link which connects to the supercomputer. All right. So let's now look at the different types of machine learning. Different types of machine learning. We have what we call the unsupervised learning. We also have supervised learning, semi-supervised learning, and reinforcement learning. All right. These are the different types of machine learning. I'll start with the unsupervised learning. I'll start to explain the unsupervised learning. In an unsupervised learning, the aim is to learn a mapping from the input to an output, whose correct values are provided by a supervisor. All right? So the correct values are provided by a supervisor. In unsupervised learning, there is no such supervisor. All right? In an unsupervised learning, there is no such supervisor. We only have input data, and the aim is to find the irregularities in the input. So there's a structure to the input space such that certain patterns occur more often than others. And we want to see what generally happens and what does not happen. In statistics, this is called density estimation. And one method for density estimation is clustering. Okay, so what I'm simply saying is we have clustering algorithms within the machine learning environment, where the aim is to find clusters or groupings of inputs. Okay, groupings of input. In the case of a company with the data of past customers, the customer data contains the demographic information as well as the past transactions with the company. And the company may want to see the distribution of the profile of its customers to see what type of customers frequently occur. So in such a case, a clustering model allocates customers similar in their attributes to the same group. So these customers, like we said before, they've got attributes. If the attributes are similar, then we cluster them, we group them. Okay, we put them in the same group. Okay, so here we're saying the learning is not supervised. The learning is not supervised, but we're just going to find patterns from the input data. And then maybe we start to cluster or to grow our customers based on the input data. All right. So at some point, we're going to be using unsupervised learning, developing models of machine learning using the unsupervised learning. Okay. You see, this clustering I'm talking about is in marketing, you call it what? Customer segmentation. So you're putting your customers into groups based on the input data, but the input data is not labeled. There is no supervision. So once such groups are found, the company may decide strategies, for example, services and products specific to different groups. Now, this is now customer relationship management. So such groupings also allows identifying those who are outliers, those who are different from other customers, which imply a niche in the market that can be further exploited by the company. But we're all picking all this from the machine learning algorithm, and this is called unsupervised learning. Okay. Now, we also have what we call supervised learning. Supervised learning, we actually have, we're predicting numerical value or classification. Okay, we're actually controlling the learning process. There's a supervisor. Okay, our data has got some labels. Okay, we're putting labels to our data. All right, and then we load this into our machine learning algorithm. Then it is able to learn. Okay, then semi-supervised learning is only part of data that is values for or classification of a target. semi-supervised, some of the data is got labels, some does not have. Then we have what we call semi-supervised learning. Then reinforcement learning now, this is another type of learning or another type of machine learning, where the output of the system is a sequence of actions, which means we're going to have multi-stage decision making. It's a sequence of actions. In such a case, a single action is not important. What is important is the policy that is the sequence of correct actions to reach the goal. There are actions in between for us to reach the goal. So we don't have the best action in any intermediate state, okay? As long as it's an intermediate state, then we don't have the best action. So in such a case, the machine learning program should be able to assess the goodness of policies and learn from the past good action sequences to be able to generate a policy. And such learning methods are called reinforcement learning algorithms. So don't worry about these different types of machine learning and what have you. What is important here is to understand, when we are now building our machine learning models, to understand whether the algorithms that I'm going to use here are going to be supervised or unsupervised or reinforcement learning, okay? And with Python, you're just going to be calling libraries, okay? You're just going to be calling these algorithms, and then you train your model. But let us just appreciate that we've got different types of machine learning. I've talked about these applications before. When you want to make a decision in terms of credit worthiness, classifying and understanding customer data, portfolio management, private equity, anti-money laundering, identifying fraudulent transactions, language translation, voice recognition, biometrics, etc. These are different application areas. There's someone who's not muted. Jeffrey. All right, maybe I can pose a question here. From this brief discussion that we have had, or this brief presentation, I want you to tell me where you think your business need machine learning in the different business that you are into, and maybe I want you to identify areas where you think you need to apply machine learning. Today you're too quiet.
By the time I was traveling, dog. So now I'm free now. My background is from an SME, so which is into distribution of cell phones, like I said before. So
Yes.
what I think machine learning would be useful in small to medium business. It's I think as for now we are giving loans, as you were saying. So the credit process, the credit screening, the screening process, I think that one we much need machine learning so that we can identify the risks associated with those customers, because we are now giving loans to our customers. So with the data that you were talking of, I think we need the data to understand if those customers do not have other loans with other institutions, so that we see the capability of repayment. I think that one would help in our SMEs.
Oh, thank you. Thank you very much. Maybe if I may ask, what kind of a database do you have in terms of keeping your customer information? Do you have a database? How do you manage customer data?
Currently, we have a database which only keeps the name of the customer and the phone number. That's all we have, and also we also have the serial number of the phone which they might have purchased. So this is the only information that we kept for customers. Like now, thank you.
All right. So you don't know about their address where they stay. You have got their. You said you've got their phone number and their name. Is that so? You don't know where they stay. You don't know their gender. You don't know. I think we need more information in terms of the customers if we were to apply, effective machine learning.
Yeah, all those other information we don't have. We only keep the phone number, the name, and the serial number for the phone which they might have purchased. That's the only information we have for the customer. Thank you.
All right. Yeah, from I mean, there's need to, now that you're doing this course, there's need to expand your database and have more attributes of the customer. Because if you are to have effective marketing, if you are to segment, to say these are the customers who are buying iPhones, all right? To have an iPhone segment or cluster. Or you can also have clustering using geographical locations. Those customers maybe will stay in Shamba or will stay in Marundera. Maybe they are the ones who are buying more of the Samsung phones and what have you. So there's need to have more information in terms of the customer attributes and also the attributes of the phone. You said you're keeping track of the serial number. But for the serial number, can we pick the type of phone to say it's an iPhone, it's a Samsung? We don't know that information, isn't it? Correct me if I'm wrong.
Yeah, possibly we don't know which phone is this unless we see, because we see from the receipts that we gave the customer, we know this is a Samsung phone and there's a serial number for that Samsung phone. But she provided the serial number only without the phone, without the receipt, you cannot identify which phone is this.
I see. Yeah. So there is, you see, there is a need to improve our computer system or our program that we're using to keep track of our customers and to keep track of the different products that we're selling to our customers, so much that if we were to apply the machine learning algorithms, it will be able to pick trends, hidden patterns and trends within your database, and then maybe help you to make decisions, to make informed decision making, and what have you. So like I was saying before, data is critical. Data is important. Machine learning can only be effective if we've got enough data. We should have enough data. One way of having enough data maybe is to have your system, maybe to have it online, or to have a website where you push these products. And then maybe as customers visit your website, you're also keeping track of their clicks and all, so much that maybe somehow you get to understand their preferences. And then so much that when you're now restocking, you're not just restocking without knowing which product sells better. You restock being guided by the sales, the rate at which these products sell. So there's that need to improve in that regard, so much that we generate huge amounts of data. Thank you, Tafadzwa, for that input. Who is next to take us through their business background and see how best machine learning can be adopted and be used in their business.
Can I come in?
Yes, go ahead.
Okay. I'm in the hospitality industry. So mostly we'll be using that application for classifying and understanding customers better. But in terms of customers' details, there's private issues sometimes where customers can come and give false details, false contact numbers. Some of them, if you don't check the ID, they'll give false names unless they are corporates or in terms of corporates who collect information, but in terms of individuals, they give false details for their private. So I just wanted to confirm how effective will be machine learning in such a scenario.
All right, thank you, Nomo. You see, when our data is not accurate, when our data has got false information, there is little that machine learning can do because it is learning from this false data, which means whatever is going to happen, the predictions and what have you, is also going to be what? To be false. So what you feed in your input data has to be correct, has to be accurate. Then the machine learning model develops or predicts from the given data. But why is it that in hospitality we have this false information from these individual customers? Why? Privacy issues.
Yes, for privacy issues.
All right. Yeah, privacy and confidentiality is very, very key, especially when you're dealing with customer data. This is why sometimes you see when you log on into these social media platforms, they ask you to agree to the terms and conditions, to agree to the whatever license. There are some are saying you are agreeing, you are consenting to their what? To giving to them using your what? Your personal information. But the question is, why is it that the corporates, they give accurate information, the individuals, they give false information? So are we saying privacy is more concerned with the individual customers and the corporates don't care about privacy? What do you think?
The issue is the purpose of the visit or the purpose of the service provided. If you look at corporates, will be providing them conferences and accommodation. Then for individuals, it will be only accommodation. Sometimes someone can, you know what happens in the hospitality industry. That's the thing.
Moneta say hospitality no more.
Mai vasiri kumba vasakazi nakazopa correct data uzotanga kusenderwa ma-thank you messages from kwanga uri haizobuda zvakanaka, so vanhu vanozopa information iyoyo yekunyeba.
All right, I see. Oh, this is where the falsehoods are coming from. I see. Well then, all right, these hotels then they will send some appreciation messages or something. All right.
Yes, especially with the technology these days, they will be sending those thank you messages. If they manage to capture even your date of birth, you can even receive your birthday message from using these applications, like what banks are doing. You can receive birthday wishes from a bank.
Yeah, I hear you. I hear you. So how best can, because as long as the input data is false, our predictions are also going to be what? They're also going to be false. But is it always the case that these individual customers, they end up giving us false information? Can't we have a situation, maybe machine learning can help us to cluster these customers, to say these ones are the ones which bring in those, you know, they come in with these, the what? The Anamainini and what have you. And these ones are the ones which come in with their wives. Can maybe machine learning can help us to then maybe have these two clusters. The moment we are able to cluster them, to put them into these groups, that these ones are okay, these ones are not okay, which is classification. And then your marketing now is going to be target marketing. If you now know that when you are sending these thank you messages, we send to this group. All right. Then if we are sending the what, the birthday, what we send to what groups or something, we can now maybe use machine learning. But for the machine learning to pick that these are false details and these details are correct, it can do that. But now you'll be using what we call the remember, supervised learning. You supervise the process. You actually label that these ones are fake, these ones are okay. All right. So like that, when you are now distributing, you're not just broadcasting messages to all the customers, but you actually know that these ones are okay, these ones are not. Something of that sort. All right. Especially, you know, in hospitality, I mean, this is a very good area to apply machine learning, because you're not only targeting local customers, you're also going to be global, isn't it? You're also going to be global. You want to market to customers who are in Asia. You want to market to customers who are in, you know what, in other continents. So there's need to apply effective machine learning. But we have to be very, very careful, because it's a thin line. It's a thin line, because once you send this thank you message and then it falls into wrong hands, we're in trouble. So maybe there's need to segment, classify your customers, and then when you're sending your messages, you know that you're sending to which group. All right, thank you very much, Nomo. But Nomo brings in the aspect of privacy and confidentiality. The moment you are using customer information, there's need for you to have consent from customers. There's need to have consent from them. Otherwise, you remember the cyber and data protection law, you might end up being in court. So you have to make sure that there's consent from your customers. All right, another scenario, another environment, another different environment where we need to apply machine learning. Tariro Shoniwa, can you come in? Yeah, I'm seeing a hand up from Anthony. Go ahead.
Okay, afternoon, say.
Good afternoon.
Just a contribution. I'm not sure if it had been mentioned, because I was having challenges with my network. So
All right, go ahead.
my area of experience or profession, I'm into gas energy. So I'm probably thinking that it's actually one of the areas which we can try to manipulate or try to get into, because it's an area of interest in the sense that we are having cases of theft by fillers who are filler gas kuma sites where. So let's say for example a site or a filler anogona kudza kuti today I've filled up maybe 520 kgs, but in actual fact obviously basing on the scale movement ema pumps and inga pump over scale, you probably realize that the cells are actually more, probably by 50 kgs or so, meaning could this person aninga a filler more, and actually he has actually pocketed the excess stuff, the excess stuff yaninga atingisa. So I'm probably thinking that we need to it's actually good or beneficial to the organization in that tika kwanisa ku implement machine learning, kwanisa ku program to detect the cells aninga ita, or probably if it's possible to dictate in real time kuti by such a period of time my cells angaitwa way so much, in the sense that it actually helps you to track any malpractices in real time, and like doing it manually, which will always be probably most of the realizer way behind. I don't know if you understand where I'm coming from.
Yeah, I hear you. Maybe as a follow-up question, do you have
Yes.
a computer system to track these cells?
Not at the moment, because the skills are at CNA, so really you can't have a software or a system you need to track them even in minimal different skills. So at the moment we are not, but it's something which we are actually thinking of investing into.
All right.
Maybe we need to upgrade our system as a whole before we venture into this MMO system.
Yeah. I think there's a need to maybe first to automate the selling process. I'm realizing something here, because every time I go and buy some gas, I don't get a receipt. I get a receipt. I doubt.
You can get a receipt and get duped as well.
Yeah, maybe a receipt from the system will be okay. You see, maybe if you can get a digital receipt, when not that these receipts which are written manually, a receipt which is coming from maybe the scale picks that this is 520 kgs, then it generates the receipt. And then that way, maybe we'll be able to, to track these cells in real time. But first, there's need to computerize the whole system, the whole selling process. Once it is computerized, then we'll be able to flag now. At the end of the day, when you close your day, when you run your report for the day, it should be able to flag that this is it should flag that this is some dubious, declarations that is happening from this outlet. Then immediately you follow up. If you're doing it manually, you realize it when it is late. So there's need maybe to automate the whole process first. Once you automate, you are guaranteed that you'll be generating what? Data. Then once we have data, then we get into machine learning. The moment we have data, we can get into what? Machine learning. We can create these models and what have you, and then we can now maybe make predictions, and we can also have a machine learning model deployed and picking these cells in real time. Yeah, but it's important that there's automation first. You mentioned the issue of the scales being different or what have you. I think the system should be able to pick the different the different scales, and then maybe you stop these leakages. All right. Thank you, Anthony, for that contribution. Nisi, do you have something to say?
Not really, sir. Not
All
really.
right. All right.
Yes.
All right. No, that's okay. That's okay. But what we are simply saying here, the bottom line is we should have data. Data either generated, normally this data is generated by a computer system. It can be from a database, it can be in Excel. There should be what? Data for us to talk about learning. For us to talk about learning, there should be data. Not only data, huge amounts of data. Let us move on. So here we have a baby data training set. This is just an example. Salary is a function of age for a certain profession in a certain area, like shown in this table here, where salary is a function of age. So we can have a scatter plot. You can actually have visual from a machine learning model. Visuals can be a scatter plot, which shows you the different salary distribution according to what? To age. And then from this plot, you can actually make some decisions. We can also have what we call a good fit, where we are now trying to draw what, a diagram from the scatter plot. We have a graph of the distribution. We can also have an out of sample validation table, okay, out of set validation table, where we're also having age and salaries. Then the scatter plot for validation sets, the plot now for the validation data. And then we can also have the fifth order polynomial model, which does not generalize well. These are visuals now, which you're generating from your what? From a model. The root mean squared error for the training data set is this. And then for the validation set is 38. We conclude that the model overfits the data. So there's issue of overfitting and underfitting of your data. So the machine learning good practice is to divide the data into 3 sets. So the best practice for machine learning is to have the training set, your training data. You also have your validation data, and then you also have your test data. Then you develop different models using the training set and examine how well they generalize to new data using the validation set. And then rule of the thumb, increase the model complexity until model no longer generalizes well to the validation set. So you'll be tracking your model, tracking the model to make sure that it is no longer generalizing well to the validation set. And then the test set is used to provide a final out of sample indication of how well the chosen model works, okay? So you can have a quadratic model for the baby data set. That's the quadratic graph, the quadratic model graph. Then you can also have a linear model for the baby data, the linear model there, where we have the salary and age, if they are directly related. And then you can also have the summary of the results, the linear model underfits while the 5th degree polynomial overfits, like shown in the table here. The training set for the polynomial of degree 5 gives us 12,000, and then the validation gives us 38. For the quadratic is 32 and 33. Then the linear model is 49. And so in this case, we can conclude that the linear model underfits, okay? And then, so the overfitting and underfitting example, predicting salary for people in a certain profession, in a certain area only with 10 observations. The first graph here shows that it's overfitting. Then this one shows underfitting. Then this is the best model, which is close. The last one there is the best, this one here. This is our best model. So once you have your best model, this is the one that that you then deploy and use for your machine learning model. Then the test set results for the quadratic model is as shown in this diagram here, this table here. The standard deviation of error is 34,273. There's also the bias variance trade-off. Bias refers to error caused by underfitting, the error caused by the underfitting. Then the variance refers to errors caused by overfitting. So we want our model not to underfit or to overfit. So the typical patterns of errors for training set and validation set is as shown here. The model error, the model complexity, the training set, the continuous line, the dashed line is the validation what? The validation set. So we also have what we call data cleaning. When you have your data, your sources of data, they come in different forms. It can be Excel, it can be your database. Then there's need to what? To clean the data. If you import the data, okay? After importing the data, then you clean the data. That's dealing with inconsistent recordings, removing unwanted observations, removing duplicates or duplication, investigating outliers, and dealing with missing what? Missing items, okay? So that's data clean. After data cleaning, then you split the data into training and test sets. Then from there, you create a model. Then you train the model, make predictions, and then you evaluate and improve the model. So the terminology that we use in machine learning, we have features, we have targets, we have labels, supervised learning, unsupervised learning, semi-supervised learning, reinforcement learning, and we have more to come. So that's about the introduction into machine learning. Do we have any questions? Because our next step now is to get into the softwares. We download Python and the Jupyter Notebook. Then I take you through the basics of Python. Then from there, when you understand Python, we get into building our machine learning model. Do we have any questions from the introduction to machine learning? Are we happy?
Yeah, so far so good, say. I'm sure the questions you ask as we go and partnering it Tafaro.
All right, that's okay. You don't hesitate to interject. If you've got anything to ask, don't hesitate to just come in, jump in and ask. All right. So let us get into the softwares. Like I said before, in this lecture, we'll be using Python.
Hello, sir.
Yes, Doc.
Yeah, because I'll be using this machine also to do the practicals. I'm asking if you can make sure that you are recording also that side. In case
I'm recording.
All right, that's okay. In case I I make some mistakes.
It's all right. It's all right, Doc. I think, let me just check, but I think I'm recording. Yes, I'm recording. So it's all right. Let us get into this software. Like I said before, Python is one of there are many tools that we can use, but Python is the most common, which is being used by industry and all. So Python is just a programming language. Okay, it's actually a programming language. So we're going to download it and get to understand how it works. Now, I want us to go on Google. Let me share my Google page. We want to do this from scratch, isn't it? We want to take you from scratch, how to download it, how to install it, then how to run it. So I'm going to share my screen on Google. I'm assuming that we are all on the Windows platform. We're all using Windows, isn't it? Is there anyone who's using Mac operating system? Is there anyone who's running on a Linux operating system? We understand there are different operating systems. I'm assuming we're all on Windows. Is that assumption correct?
I'm Windows.
Windows.
Yeah, I'm sure many of us are on the Windows platform. All right, so I'm going to share. Let me share this. Can you see my screen?
Yes, sir.
Can you see? Yes. So I'm on Google. All right. So I expect you to also to be on Google. Can you go on Google? Then we're going to look for Anaconda. Anaconda, let's say Anaconda download. Anaconda, not the snake, but Anaconda, the developing environment. I hope you are following. As I'm typing, you're also doing that. I hope you are following, isn't it? So you type Anaconda download. Are we there? Then you go to this page here where it says free download for Anaconda. Then we want to download Anaconda for.
Send it to Steve.
All right, Anaconda. So if you can see my mouse here, we have Anaconda for Windows, and then we have Anaconda for the Mac operating system for Apple. All right. So we want Anaconda for Windows. This one here. So we click this Windows tab. Are we there? All right. For Windows. Okay. So if I see download here, then my machine has got the download manager, so it's going to download using Internet Download Manager. Any problems, please just interject. If you're having challenges, just say it out. Are we winning? Are we winning downloading Anaconda?
Yeah, I'm winning.
Good. So Anaconda is actually a package which has got Python inside of it. It also has got Jupyter, which is the notebook that we use for typing these Python commands. All right. This silence, is it okay? Is everything all right? Should we time?
Yeah, I think mine is moving. It's one with about 890 something MB, right?
Yes.
Okay.
So
It's work in progress.
Yeah, that's good. Depending with your internet speed now. If you've got fast connectivity, it doesn't take time.
My speed is about 1,000 KB per second.
All right, it's not bad.
By then.
So you just alert when you are done, when it is done downloading.
Tremora Garupita.
Anthony, are you winning?
Almost done.
Good.
Yes, I'm winning. I think I'm left with about 3 minutes or so.
That's okay. So I'm seeing some who are joining. We are at a stage where we are downloading the software that we want to use for machine learning. So we are downloading what we call Anaconda. You go on Google, then you search for Anaconda download, you select the one for Windows, you download. Then when you download, then we take it up from there. Doc, I'm thinking maybe we can pause the recording. Maybe let's say by 3 o'clock, I think most of us would have finished downloading. Is that so? Then maybe we continue from 3 o'clock, if it's okay, because we might end up having a very big file, which we might have challenges to share. What do you
Okay,
think?
that's fine. You can pause the recording.
That's fine.
All right. So once you have downloaded our Anaconda, normally it comes down as a compressed file. Is that so? Is the download a compressed file? Hello? Right. Can we install our, do you see your Anaconda 3, what file? Do you see the file?
Yes, sir.
Yes. Can you double click on the file so that it starts to install? Let's double click on the file. And tell me what's happening.
Mine is not a zip file, but when I clicked, it took me to Anaconda and says next.
Yes. So let's click next. That's the installation process.
Okay. Then we agree to the license.
To the license. Yes.
Then just me, right? For users.
Sorry?
It says install, then just me or all users.
All right, yeah, it's asking for the option whether if you've got more than one account on your computer, then you can say all users. If you want it just for your account, just me.
Then it's got 4 options. It says one, create start menu shortcut. Then the other one, add Anaconda 3 to path environment variable. Then it says register Anaconda as my default Python 3 what. And then it says clear the package cache upon completion.
Yeah, I think it's okay. It's asking for Anaconda to be included on the start menu, and then to clear the cache, the temporal files for installation after successful installation. So just click What is the option, next or finish?
No, these ones are not selected. Should we select them? The other
Yeah,
three.
select them. Yes, select them, then move to the next.
It's already.
You already had the Anaconda.
I'm not sure
Okay.
now.
Okay. Say, let me just try to make you
Maybe you can
understand.
share what you can you share your screen
my
so
other
that I can
colleague-
see.
Okay. Right. Can you see my screen now?
Yes, I can see your screen. The version of Python 3.1 is already at, so you already had Python installed, I think. So you can click those boxes. This can lead to conflicts with other applications. Add another to my path into the message, use the command prompt and PowerShell. Yeah, just select. And then a version of 3.11 is already registered this way. If you really know this is what you want, click OK. Just click OK. It's saying you already had Python 3.11 installed. Just click OK.
Can I click?
Install. Yes.
My computer is also stuck on the same stage.
Maybe Dr. Famba can stop sharing, then maybe you can share so that we can see which stage you are on. Can you share, Nisi?
All right.
Yeah, no, this is all right. It's actually installing. So it's communicating with you here when we're saying setting up the package, cache, and all. That's the stage at which it is at.
Okay, so there's no problem.
Yes, it's in order.
Okay.
So please alert once done. Are we making any progress?
It's still on that stage, but it seems as if it's moving.
All right. Yeah, maybe it has got something to do with the, how much RAM do you have? How much RAM? And how much speed are you running on?
I've got good RAM. I think my RAM should be, is it 16?
Oh, that's good.
Yeah. And
That's good RAM.
I just don't know why it is slow.
Maybe you're having too many applications running.
Yeah, maybe.
And also, you remember you had some Python installed. Maybe it's removing that first, then installing the new one and whatever.
Okay.
So I'm also thinking maybe during the midweek, I can also arrange maybe some tutorial on Python, because we need to be grounded in Python and whatever. So I'm thinking midweek we can also have another, I don't know, maybe Wednesday, depending with availability of you guys, we can have another tutorial on Python and so on, so that we master this language.
I think that would be a great opportunity for all of us. For personally, I will avail the time. I don't know the other guys.
Yeah.
No worries, no worries.
Yeah, that's fine.
So provisionally, what time can you expect?
On time, maybe I can hear from you guys. What time will you be available? Let's agree. Let's discuss on time and date.
So since it's midweek, is it not wise to have it maybe after 7? I don't know.
Yeah, I was also thinking along those lines.
I have no problem with that.
Well, with my schedule, I'll be very much occupied in the morning. So from my end, after lunch would do for me. I don't know for others, but with my schedule, it will be tricky to join, or maybe I'll just have to rely on the recording. But it's very tricky for me in the morning.
So maybe we can have it around 7 p.m., maybe 7 to 9, 7, around that time. So I'll communicate the finer details later as to when and what time, but it will be after hours. So when it's done installation, please alert.
Done installation.
All right, that's good. When it's done, can you now run, click on start and run start your Anaconda. Normally, it should after launching, you should have a page like this. So let me share my screen. We should have a page like this one here. Do you see the screen?
Yes, sir.
Yes.
We should have, yeah, we should have a page like this one where we can see all these components have been installed via the Anaconda Navigator. We have the Jupyter Notebook, Jupyter Lab. We also have R Studio installed. So once we are on this stage here, we can launch the Jupyter Notebook. This is the notebook that we use to write the code and what have you. It's actually interactive. Nisi, have you managed to launch?
It's launching.
All right.
Good. Yes.
Good. I'm sure my other colleagues here are not on, they are not on their laptops. Maybe they are using their mobiles. But I think we'll share the recording. Once they are on their computer, they'll be able to replicate what we are doing now and have some, feel of the Python code and what have you.
Jupyter is successfully loaded.
Can you share your screen? Yes, wonderful. So that's the Jupyter Notebook. Normally, it runs via the browser, either Mozilla, or it can be Chrome, or it can be Edge. And then it runs on the local host. As you can see, local host, we have quad 8 and 3. Then you'll be able to see all the folders. That's our Jupyter Notebook. Okay. So let's just wait for others to launch their notebooks. Dr. Famba, is it done? Can you share your screen? All right. It's extracting history. Yeah, maybe I think mainly it's because there was some installation before, so maybe it is trying to maintain the history from the previous installation and what it is.
Okay.
Can you click on show details there? All right. And extract history. No, that's fine. Let's give it time.
Hello, sir.
Yes, Doc.
Maybe since some of these are taking too long, if there is someone who has managed to install, we could probably follow using yours and that of the other. colleague.
All right. No, that's fine. That's fine. So I will ask, I think it would be better if Nisi does it from his end, then we follow. So I'll ask Nisi to share his screen.
All right, sure, no worries. Can you all see my screen?
Yes, thank you very much, Nisi.
Yes, it's
So,
very clear.
yes. So Nisi is using this Jupyter Notebook is launched using Mozilla Firefox. All right. So as you can see, the Jupyter Notebook uses the local host at the top here, where it says localhost quad 8 tree notebooks. Okay, to use the local host. And just after Jupyter there, do you see where it's written files running in clusters? Do you see that part? Yes, that part. All right. These are the tabs that we have. Okay. So files, when you're, in this case, we've clicked files, we're under files. It's like we're in the home directory. All right. You can see the desktop, you can see the documents, your normal documents, your downloads, all your folders, you see them under files. All right. So we want to launch our first Jupyter notebook. So we're going to click on desktop. Can you click desktop? Right. And then at the far right corner, do you see where it's written new? Yes, click on new. Then you click on Python 3. All right. So it's going to launch our first notebook. Yes, there we are. So our first Jupyter notebook, it does not have a name. It's untitled. So do you see where it's written untitled? Yes, let's click on that. And then let's give it a title. Let's say Hello World. That's the notebook name. Hello World. Yes. So this is our first notebook. Do you see where it's written line? This is where we type our commands. Yes, this is where we're going to type our commands. All right. But before we type our commands, I want you to minimize this notebook. I want you to look at the desktop. Minimize. Can you minimize the Mozilla Firefox window? I want us to see your desktop. You'll be able to see our Jupyter notebook written Hello World on the desktop as a file. Nisi?
All right, so let me share.
Yes.
Post
yeah, open the desktop and share. Nisi?
Can you see my screen now?
No, we're seeing the old screen. Can you stop sharing first and then share the screen where you have opened the desktop?
Okay. What about now?
Yes, we can see the desktop now. I want us to look for that file. Yeah, hello world. Yes.
Okay.
Can you right click?
Uh-huh.
Just this was a left click. Just close it. I want you to right click it and go to properties. Right click. Then properties, left click. As you can see, this is the file type of file. Do you see the type of file there? This is a Jupyter what? Notebook file. Yes, it's a Jupyter notebook file. Now close that and then open our notebook, our Jupyter notebook, and share. Or share the notebook now. Yes, the Jupyter notebook. Good. Can you click on yes? Good. Now I want you to type print hello world. Print. Don't put double. Just put a bracket. Put a bracket there. Oh, then a single quote, inverted comma, not double. Yeah, just okay, fine. You can use double, it's all right. But you just have to be consistent. Then type hello world. Then do you see where it says run at the top there? If you click run, can you click run? Do you see the output? We've just created our first Python code to print hello world. All right, and it prints hello world. So if you want to say print whatever name that you put within those codes, the Python code is going to run and print that. All right. So that's an example of what a Python code. All right. But now we want to load our first. Maybe before we get into machine learning, maybe I'll do that during the midweek where we get to more in terms of Python code and all. But for now, let us load our first. But do we have a data set? We don't have a data set. We need to download the data set. So that we can import, because the steps for creating a machine learning model is first we need to import the data set. We need to import it, but in this case we don't have a data set. So I want us to I want Nisi to go to click on the next tab there on your Mozilla Firefox. Next tab, yes, there. Then search for Kaggle, Kaggle. This is a site which has got quite a number of data sets. Now, can you click the first one there? Kaggle, your machine learning and data set. That's a site which is full of data sets that we use for learning purposes. You see, like in developed countries, after they declassify their data, they avail it for research purposes. So this is a site which contains quite a number of data sets. All right. So I want you to, for us to be able to download, I think we should be registered. Can you try to search for a data set called, let's look for what? We have a data set for, do I remember? Let me check in my machine the data set that I once used. Then we download that and we use that. Doc, I hope you're done installing.
No, I'm not yet done installing. I think there is the issue of the previous installation is what is giving the problem. But but I'm following.
All right, that's okay. So we want to download a video games sales data set. So I want NIST to search for video game sales. Data set for video games. Yes, video game sales. Click on that. Yeah, the one with the red one, the one at the top there. Yes, click on that one. You see, the unfortunate thing here, we're using data sets from other countries. If we're data sets within our environment, we can use that, but I think we can still use it later on. But now for demonstration purposes, let us download. Click on download. Let us use this data set here. At the top there, you see download, which is 390 kilobytes. It requires you to create an account. You can't just download from Kaggle without an account. So sign in with Google. If you have a Google account logged in, you can sign in with Google. You use your Google account to sign in. So here we're just trying to download a data set that we want to use for our model. Yeah, it wants to verify, two-step verification. You have to confirm on your Galaxy A20 there. Click on yes so that it continued. I agree. So you're agreeing to the terms without reading. Normally we just say agree. Now download. I think you now have an account. Yes, it's now downloading. Good. So the download is actually an archive. It's a zip file. Can you click? It's done downloading. Click the archive file. Okay, open it. Close. So this is a video game sales.csv, which means it's an Excel file. Okay, maybe you can copy it to the desktop. Copy it to the desktop. Yes. So maybe I can say something about Kaggle. Kaggle has got quite a number of these these data sets that we can use for learning purposes and what have you. Then we can download there and then we can use it for demonstration purposes. So this is our data set. As you can see, it has got rank, name, platform, year, genre, publisher, NA sales, European sales, JP sales, other sales, global sales. Can you scroll down to see how many tuples or how many records, how many rows do we have here? I think you have to drag because it's almost 16,500 records. I think that is enough, good enough for us to develop a machine learning model. So minimize the Excel. Now let's get into our Jupyter notebook. Yes. So the first thing here is to load the data set. So I want you to, where we have written print hello world, I want you to go back there and say import pandas as PD. Just remove everything there. Pandas SPD. So that's a very important library called pandas that we're importing. Very important for for machine learning. Then can you press enter, type pd.read, pd.read underscore CSV, open bracket, open quote, VG cells, that's the file name. Remember the file name that of our data set is VG cells.csv. Right. So we've just said VG cells.csv because we know that our data set is just next to our Jupyter notebook file on the desktop. Otherwise, if we had saved it into my documents, we put the path here, all right? To say C documents, what. All right. So in this case, it's just next to it. So before pd.read, just before, can you go back there? Just before, yes. Then type df is equal to, yes, is equal to that. And then go at the end, press enter. Write df. Now run the program. Yes. So it loads our data set. It is like I was saying, the first step is to import the data set. We've just imported our data set. All right. You can scroll down and see how the data set looks like. The rank, the name, the platform, yeah, genre. So this is our data set. It tells us it has got at the end the 16,598 rows times 11 columns. All right. So we've just loaded our data set into our Python environment. All right. So we can also, I want you to type df.shape. df.shape. Yes, shape.
Okay.
Then can you run that? Yes, good. It tells us the shape, isn't it? That we have 16,598 rows and 11 what? Columns. That's the shape of our data set. Do we follow?
Yes, sir.
Yes.
Yeah, if you've got something to say, just interject, isn't it? Just interject, and so that we move together, isn't it? That's the so df.shape tells us the shape of our data set, the structure of our data set. It has got 16,598 rows and 11 columns. All right. No. Now, if you can see clearly, you notice that we have two segments of writing codes here. We've got the line 3, and then the other one, the output for line 3, then the other one there, yes. So we've got these are cells, all right, that we can have within our Jupyter notebook. So we can write, we can use the other cell to write the methods for the data frame. df.describe, can you write df.describe? Open and close bracket. Can you run that? What do you say? Can someone explain? What is that?
So that's the descriptive statistics for that
Yes.
data. Yes.
Yes. All right. So this is how you do it in Python to see the description. All right. But I want you to notice here that we've got the first line, and it has got this one output, and then we have the second line, which is line 4 here in this case, and it has got this one what? Output. Okay. All right. So I want us to, I want you to see the beauty of Jupyter. You can actually see clearly the visual, isn't it? From the first cell, you see the output. The second cell, you also see the output. We could have used any other text editing software like Notepad and all, but it's not as user-friendly as as the Jupyter Notebook. Okay, Jupyter Notebook, you can actually write and see and load whatever you want to see within your notebook. Okay.
Yes.
So the describe gives us the description, rank. This is the count, isn't it? The number of what? The number of rows that we have. For rank is 16,598, and then for year, 16,327. It means there are some rows which is got inconsistent values, because the number of rows under rank and the number of rows under year are not adding up, are not tallying, which means we have some null values. We've got some rows which do not have values. All right, which means our data needs to be what? To be cleaned before we develop it for our machine learning model. All right, because if you develop a model using a data which has not been cleaned, which is dirty, it means the predictions or whatever we're going to generate from the machine learning model will have errors and challenges. So we make sure that we clean our model. Again, you can see that we have the mean. All right, which is the mean, the standard deviation, the minimum value, the median, the maximum value. You can see that the minimum here is 1980. Do you see that?
Huh?
80. What about the mean? The mean here. The mean here. The average here. No, the mean, we have the minimum and then the mean. Do you see that? Yes, it's 2000 and what? 2006 is the average what? The average year. All right. Okay. So describe there gives us the description of all the what? Of our data set, the description of our data set. All right. So let's go to the next segment. Just scroll down. DF values, df.values. Run that. Yes, it now shows you that it's morphing array. In array, in computer science, an array is a data type. We've got quite a number of data types. I think we'll talk about it during the midweek lecture. We've got quite a number of data types that we use in programming, like integers, with string and all. So we also have got what we call an array. So this one is a two-dimensional array. We've got the first square bracket, then the second square bracket, which means the first tuple within this data set is 1, we sports, we 3.77. That's the first tuple, first record within our data set. It shows us the values. So df.values shows us the values in our what? Just a sample, not all the values within our data set. Okay. So you're trying to understand your data set before you try to create a machine learning model or to train it. You're trying to understand your data set, which is very, very important. Okay. So let's move to the next stage. What else can we talk about here? There are quite a number of keyboards, shortcuts that we can use within Jupyter, but I think that's for another day. Now, I want you to type df.describe. df.describe. I want you to you type describe, yes? Can you delete describe? Can you press Shift tab? Yes. Then Shift tab, can you scroll down? It tells you the parameters, isn't it? The parameters that you can describe the index, the columns, the data type, the copy, bool for Boolean, none, default for none. So I think we can explore these other options during the week, because if we load you with a lot of information now, you might end up getting confused. So I think we need to do it one step at a time, slowly, so that you get to understand and appreciate what programming. And then the other thing with programming is about, you have to like it. You have to enjoy doing it, you see. Because you're getting the computer instruction on what to do and what to execute. All right? So you need to but with Python, programming is actually interesting with Python. So you can close there with that X there, you can close that sub window. Remember we said the steps for machine learning is import, then we clean the data, then we split the data into training and test data. Then we create our model, we train the model, we make predictions, and then finally we evaluate and improve our model. So we've done the first step, which is to import the CSV file with the video column. Now, I want us to before we get into more detail in terms of developing our model for machine learning, I think it's critical that we focus.
Hello, sir. Hello, sir. I think we have lost you.
We can't hear now.
He has just lost power. I think Pindura does, there's a bit of injustice. Most of the times around about this time, they switch off power.
So what do we do, sir?
Just a moment, I'm actually inquiring with him. Hello, colleagues.
No, sir.
I think the issue of power is beyond his control. And since he has already allocated us some time during the week, I think we can just excuse ourselves. And then I'm just talking to him and he's saying we can compensate that time during the week.
All right, sir. Thank you.
Okay, no problem.
Thank
Thank
you
you,
very
sir.
much, colleagues. This is quite exciting, and I'm actually raring to go. You can see I'm also in the classroom. So, guys, let's keep the fire burning.
Thank you, sir.
Thank you so much.